Hello everyone. In this video, we will explain a few questions based on WAVY curve method. This video is WAVY curve method 2. In video 1, I have explained that how to find out the interval of x for which the given expression is positive, negative, or greater than or equal to 0 or less than or equal to 0. So if you watch that video, then you can understand the problems which I am going to solve in this video, right? So here are a few steps before we solve inequations. Step one is factorize both numerator and denominator expression into linear factors. Step 2, make sure that the coefficient of x in each linear factor is positive. The coefficient of x in each linear factor is positive. Second, step 3 is if coefficient of x in some linear factors of given inequality are negative, then multiply each such factor by -1. Then multiply each such factor by -1. Step 4, find all zeros and poles of given expression and plot them on real line. Now apply the rules of WAVY curve method. So to understand that rules of WAVY curve method, you must watch the video 1 on WAVY curve method. Now I am going to solve a few inequations. These are very helpful and very useful in solving quadratic inequations or in finding domain of a function in functions, or you can say finding intervals of increasing and decreasing of some functions in calculus, etc. So many variety of questions you can find the use of WAVY curve method. Well, you see here, I will write that let alpha comma beta belongs to R. They are real numbers and alpha less than beta. Right. So here you see x minus alpha into x minus beta is less than 0. Then x belongs to which interval? X minus alpha into x minus beta. Okay. I will keep here less than or equal to, here I will keep greater than or equal. Then x belongs to which interval? So for this, you know that you have to draw a real line. Real line is drawn. Well, so you have to plot the zeros and poles on the real line. Here you say this is alpha and this is beta. Okay. Here you observe each factor is repeated only once. So each factor is repeated only once. So x minus alpha whole power 1, x minus beta whole power 1. So rightmost is always positive, right? You can directly write negative sign and here positive sign. We want that this expression less than or equal to 0. So if you take any value between that alpha and beta, then the expression is negative. So here x belongs to, directly you can write alpha to beta. You see the next one. We want that x minus alpha into x minus beta greater than or equal to 0. So you have to search for positive sign. Here is the positive sign, beta to infinity, minus infinity to alpha. So x belongs to minus infinity to alpha union beta to infinity. If you want to solve a strict inequality, let us say x minus alpha into x minus beta. Well, let us say this is less than 0. Then you have to take only open interval, because anyway we want that the product is strictly less than 0. So exclude the end points. X belongs to alpha to beta. If we want that x minus alpha into x minus beta greater than 0, this is nothing but same as of above. Only the point is you have to exclude alpha and beta. So x belongs to minus infinity to alpha, here open, union beta to infinity. So in this way, you can find the intervals of x very directly. Suppose if they have given x minus alpha by x minus beta, suppose they have given like this. So this you can write, multiply both numerator and denominator by x minus beta whole by x minus beta whole square. Here, of course, that x minus beta is not equal to 0. Assume this is f of x, and here x not equal to beta, because it is in denominator. Now we want to find out that f of x greater than or equal to 0. See, f of x greater than or equal to 0. Well, so x minus alpha into x minus beta, right? See, this denominator is already positive. We want that f of x greater than or equal to 0. Then numerator also must be greater than or equal to 0. So we'll use the above one, that we want this is greater than or equal to 0. So x belongs to minus infinity to alpha closed, isn't it? Union, here x is not equal to beta, so you have to keep that beta is in open interval, beta to infinity. If we ask f of x less than or equal to 0, this implies, say anyway denominator is positive. We want that f of x less than or equal to 0. So when denominator is positive, numerator must be less than or equal to 0. Like this. So now x belongs to closed alpha and open beta. You must notice this small change when ratio of functions are given, ratio of expressions are given. Let us take another example. Okay. Sometimes they do not give directly into the linear factors. So it is our responsibility to factorize a given expression in numerator and in denominator. For example, f of x equal to, you take that x square minus 3x plus 2. Right. You take this. Now we have to factorize this. Anyway, we know how to factorize the quadratic expressions. Well, so this is, I'm writing directly x minus 1 into x minus 2. Because my aim is not factorizing this. Anyway, that you learn in another video, right? So this, we want that greater than or equal to 0. Okay. So here you keep the real line are not necessary. Using the above fact, f of x greater than or equal to 0 implies here this is alpha, this is beta. So we want that x belongs to minus infinity to alpha. So minus infinity to 1 closed union 2 to infinity. Or if you do not remember the above formula, there is no problem at all. Just you take the real line. This is the real line. Okay. Plot the zeros. Here, 1 0 is 1, another one is 2. Right? You keep the positive sign rightmost on the real line. Now change the sign. Anyway, here the powers of each factor is odd. So now here plus. So minus infinity to 1 and 2 to infinity, that expression is greater than or equal to 0. Suppose we want that f of x is strictly less than 0. So less than 0 means you have to consider the negative sign interval. So between 1 and 2, that expression is negative. So you can write x belongs to 1 comma 2. In this way, you can solve any question. Once you understand that WAVY method or sign rule, how to change the sign, how to change them. If the root of multiplicity of given factor, linear factor, is odd, sign will be changed. If the root of multiplicity is even, then sign will not be changed. Here you see one expression, solve this inequality. Here we have a 3 linear factors. In first linear factor, x coefficient is positive. Second linear factor, x coefficient is positive. Whereas in third linear factor, here x coefficient is negative, right? So here x coefficient is negative. So what we have to do is, you just multiply with negative 1. So here this is x minus 1. First one remains same. Second one remains same. Third one, 2x minus 1. When you are multiplying by a negative 1 to the inequality will be reversed. So this is reversed. Right? Now, see, this is 0 when x equal to 1. This is 0 when x equal to 2. This is 0 when x equal to 1 by 2. Now you plot all these numbers on the real line. So this is 1 by 2, right? And the next one is 1. And the next one is 2. Now observe the power of each linear factor is odd. The power of each linear factor is odd. Whether I give power 1 or power 3 or power 5 or power 7, any odd power is given, but the solution is same. So now here keep always positive sign. Well, okay. Now keep on change the sign. When odd power is there, without looking that, you just change the sign. Plus, minus. Well, so for only beautification or beautiness, I'll draw a wavy curve. That wavy curve is like this. See, this is the minus sign, like this. Only to understand clearly. Now, We want that this expression is negative. You find where are the negative signs. So x belongs to, here is the negative sign for our solution. This is the feasible region, minus infinity to 1 by 2, union, the feasible region is here, 1 to 2. That's it. Answer is over. Very simple. You just find the linear factors and you see where each linear factor is 0. You plot all these numbers on a real line. Now keep the positive sign on rightmost of the real line. Now keep on changing the sign. If the power of linear factor is odd, if the power of linear factor is even, do not change the sign. Okay, these sign changes will take from right to left, from right to left. Okay, now coming to the second one, solve this inequality. You see here one factor is there, x coefficient is positive and odd power. Here x coefficient is positive, here x coefficient is positive, here x coefficient is positive, x coefficient is positive. Now 1, 2, 3, 4, 5 linear factors are there, right? Now plot all these right, roots of this expression, roots of this expression. So the first one is 0 when x equal to 0. And this is 0 when x equal to minus 2. And this is 0 when x equal to 1. And this is 0 when x equal to 3 by 2. And this is 0 when x equal to 3. Okay. Since the coefficient of x in each linear factor is positive, right? Now keep positive sign on rightmost on the real line. So keep the positive sign here. This is positive sign, right? Now corresponding to 3, here you check the power is even. So there is no sign change at all. So there is no sign change. Now corresponding to 3 by 2, here power is 1. So this is odd. So there will be a sign change. So from plus to minus. Now corresponding to 1, here you see this power is odd. Now again sign will be changed from negative to positive. Now corresponding to 0, this power is odd. Again sign will be changed. So minus sign. Now finally corresponding to minus 2, here this power is even. When even power comes, there will be no change in the sign. So here you have to keep the negative sign. We want that expression is greater than or equal to 0. So the expression is 0. Okay. So therefore we want that greater than or equal to 0. So now the answer is, well, so x belongs to, you find the positive signs, only positive signs. Here is the positive sign and here is the positive sign. So x belongs to 0 to 1. 0 to 1. Closed because we want greater than or equal to 0. Union 3 by 2 to infinity. 3 by 2 to infinity. But still problem is not yet finished. This answer is wrong because the given expression is 0 when x equal to 0, when x equal to minus 2, when x equal to 1, when x equal to 3 by 2, when x equal to 3. So all these numbers must be included in the solution. Here 0 is included, 1 is included, 3 by 2 is included. We have totally 5 factors. Of course, 3 is included in this interval. Only -2 is not included. So you must take care of that. Union set -2. This is the solution. So for practice, you can do that. This question, what values of x? This expression is less than or equal to 0. So here is a rational expression, numerator and denominator, ratio of 2 expressions. We want to solve this expression. So take care that the coefficient of x in each factor must be positive. Well, see, this is a linear factor x plus 2 that is given directly. Okay, so I'll rewrite this inequation once again. X plus 2 is there. This is x minus 1 whole square. Well, see what is there in denominator, right? In denominator, I'll take a negative sign common. X square minus 3x minus 4 greater than or equal to 0. Well, okay, so here you see minus a greater than or equal to 0 is nothing but a is less than or equal to 0. Just multiply with minus 1. Just multiply with minus 1. So here, this implies that x plus 2 into x minus 1 whole square whole by, I can factorize this. This is directly x minus 4 into x plus 1 less than or equal to 0. Follow this fact. So now numerator and denominator is factorized into linear factors. Now it is time to plot the roots and the poles on the real line. This is the real line. Well, so this first factor is 0 when x equal to minus 2. And this factor is 0 when x equal to 1. And this factor is 0 when x equal to minus 1. Okay, I'll keep here and plus 1 here. And this factor is 0 when x equal to 4. X plus 1. Here we have 3 odd powers and 1 even power, right? So you will see the sign changes at 3 places and you will see no sign change at only 1 place. Now keep the positive sign on the rightmost, positive. Now corresponding to 4, the root of multiplicity is 1. So there is a sign change, right? At 1, you see, be careful. Whole square is there, even power. So there is no sign change. There is no sign change. Now, at minus 1, odd power is there. So there is a sign change. And at minus 2, odd power is there. There is a sign change. So question is solved. Now, you just, if you want to, it is not necessary to draw this wavy curve when you are solving a question in your notes because it will waste your time. Like this. So we want that expression is less than or equal to 0. Okay. So the less than or equal to 0. So the answer is we want to see the only negative signs. So negative sign is there, minus infinity to minus 2. Okay. So x belongs to minus infinity to minus 2. Okay. And remember, at roots or zeros, keep the dark circles. Okay, here. At poles, you keep whole because we, at any cost, we should not include these numbers in the solution. Right? We should not include these numbers in the solution. So x belongs to minus infinity to minus 2 union, where you can find a negative sign. Here you see minus 1 to 4. Minus 1 to 4. These are the open interval. Now, whether you see whether all points included or not, here the numerator becomes 0 when x equal to minus 2 and when x equal to 1. Anyway, 1 is in between minus 1 and 4. So this is the correct answer.